let's pick up in 4-7. Now, I started 4-7 a little bit on Friday. Friday was a 2-hour delay. We had a homework to check, so we didn't get a whole bunch into it, but I did start it a little bit. I'm going to try and recap some because I also know we had like 5 of you guys out. So we started talking about inverse functions. We specifically started talking about inverse sine function. So if you remember when we were doing our reciprocals, and I said do not use that sine to the -1 button, that's because it's the inverse, which is not the same as a reciprocal. Okay? Remember, domain are your x values. The domain of the sine function is -1 to 1. So the only inputs you can have on inverse sine are -1 to 1. The range of the inverse sine function is -π/2 to +π/2. So those are the only outputs you can have there. And then, if you recall anything about inverses, and this is a review for everybody, right? If it's an inverse, what happens from a regular function to an inverse function? The x and y switch, right? And so normally if I say, what is the sine of π/4, I'm asking you the sine of an angle, you're giving me a number answer. Now reverse it. When I'm asking about sine inverse, it's going to be, what is the sine inverse of a number answer? And you're going to be giving me an angle answer. And so that's the next part there. Real quick, I'm going to flip you to the back side of your notes. And on the back side of your notes, there are 3 half circles. Okay? I'm only talking about the first one right now, which is sine inverse. And what it is this is a picture representation of our range values. So this is a representation of what kind of answers you can give when I ask a sine inverse question. Okay? So you can give anything in quadrant 1 or the equivalence of quadrant 4. But when you name it, it has to be from -π/2 to +π/2. So, for example, like -π/6 here. If you look on a regular unit circle, it's the equivalence of 11π/6. But you couldn't tell me 11π/6 for an inverse sine answer. You'd have to say -π/6. So we're giving these answers when you have an inverse sine. Basically, if you need a positive, if they give you a positive number, you're going to give me a quadrant 1 answer. If they want to know the sine inverse of, say, -1/2, you're going to give me a quadrant 4 answer. Okay? Now, as a class on Friday, we did A and B. And then I wanted to come back and talk about C was a good stopping place. So if we look at A wanted the sine inverse of 1/2. And having your unit circles and the charts out are a good thing to have right now by your side, especially probably that chart. Okay. Sine inverse of 1/2. So you're asking yourself, at what angle does sine equal 1/2? And if you look on your chart, where does sine equal 1/2? And that is π/6, right? Where is mine? So right here, sine equals 1/2 at 30 degrees or π/6. We tend to give radian answers unless they specify they want degrees. Okay? Now, with it in mind, you always want to be checking, are these, we obviously know π/6 is in our possible range values. And I should have done this before we started, but is 1/2 a good domain value? Does that fall in the possible domain values of -1 to 1? And it does. Because if that's not a valid domain value, you can't answer the question. Okay, so π/6 is our answer there. Now, B. Kind of the difference on B, it's the sine inverse again. This time it's -√3/2. Well, where does sine equal √3/2 on your chart? That's happening at 60 degrees or π/3, correct? Now, if it was the sine inverse of positive square root of 3 over 2, okay, piece of cake. We would just give pi over 3. But it says negative square root of 3 over 2. So negative square root of 3 over 2 is going to push us down to the quadrant 4, right? Because this is where sine is negative. Remember, all students take calculus. Sine is positive quadrant 1, negative in quadrant 4. Now, what is the equivalence of pi over 3 up above? If you're looking at your unit circle, I heard 5 pi over 3 there, yes? Which is good thinking. However, can I give 5 pi over 3 as an answer? No. Look at your half circle on the back. 5 pi over 3, that is if you go around the circle positively. What is this if you go around the circle negatively? And it's negative, the equivalence of negative pi over 3. Okay? So I'm looking for an answer of negative pi over 3 there. Again, I'm trying to be quick here because I want to get to the rest of this. Check your domain and range. Okay? Obviously, we just talked about range. Domain, that negative square root of 3 over 2, does that fall in that domain of negative 1 to 1? Which it does, so we're good. Okay? Did we get a basic understanding there? Review for those of you that were there Friday. Basic intro for those of you that weren't there Friday. Because now we got to talk about C. C is asking me for the sine inverse of pi over 2. What? No. No.
2 over 5. Negative 2 over 1.
Okay, so first of all, what's different about the setup of this one? Okay, they're giving us what appears to be an angle. Okay? Now, here's the deal. My angle is supposed to be my answer. So if this said, what is the sine of pi over 2? I would agree with the answer of 1. However, is that what this says? This says the sine inverse of pi over 2. So what we need to know here, this pi over 2, guys, it's not an angle. Your domain on sine inverse is not an angle. It's just a number between negative 1 and 1. Okay, so this right here, this is your domain. That's the part you've got to remember here. What is pi divided by 2 as a number? No, okay, so pi over 2 is radians, 90 degrees is degrees, but this is not an angle. So what is the fraction of pi over 2 equal to as just a regular old number? As in, what is pi divided by 2? What? 1 point something? Yep, there you go. Okay, so the idea that I'm trying to get you guys to go to is if you take pi and divide it by 2, it is 1.57 something, something, something. What is important about that? It's not in between negative 1 and 1. It is greater than 1. So can I take the sine inverse of pi over 2? No, I cannot do this problem because that is not an appropriate domain. So the sine inverse of pi over 2 does not exist. And my reasoning? Because outside the domain. Okay. That type of problem thrown in there purely to trick you, if you ask my opinion. Okay. Because automatically, when you guys saw pi over 2, several of you said, oh, the sine of pi over 2 is 1. My answer is 1. But you have to remember, for the inverse functions, we have to give an angle answer. And so pi over 2, even though it's in the form of a fraction, it's not really a fraction. It's just a number. Okay, questions on that one? Okay, let's try D. D says the sine inverse of sine of pi over 3. Well, as a math student, what are you trained to do when you see multiple parentheses?
Distribute.
Try another answer.
I like distribute.
There's nothing, okay, not distribute because there's nothing outside to distribute. I get it, valid point, but. Okay, how about start on the inside? That's the direction I was going for. I'll give you credit. Okay, you see the parentheses distribute. Not what I wanted, but okay. What I'm trying to get you guys to think of is when you see multiple sets of parentheses, let me phrase it that way, multiple sets of parentheses, start inside and work your way out. So, forget sine inverse for a moment. What is the sine of pi over 3? The sine of pi over 3, according to my chart, is square root of 3 over 2. Correct? So now, what that means is my insides here is equivalent to square root of 3 over 2. What do I still have left on the outside? Sine inverse. So now, we've done the insides, and that inside was a regular sine, so you gave me a number answer. Now it's sine inverse of square root of 3 over 2. So now it's, at what angle does sine equal square root of 3 over 2? Pi over 3. We didn't have any sign changes, so to speak. And we went from, we were in quadrant 1 with pi over 3, positive square root of 3 over 2. We are still in quadrant 1. So pi over 3. The point there is that what are a sine inverse and a sine function going to do to each other? They're going to undo each other, right? Cancel each other out, undo each other, however you want to think about it. Now, you have to be careful because it's not always that. Don't just get into that, oh, they're going to do each other, I'm just going to write down pi over 3. Be careful with that thought. This one worked pretty easily because pi over 3 is in our appropriate range. Okay, let's try C. Excuse me, E. I don't know my alphabet today. Sine inverse of sine of 5 pi over 6. Okay, so like the last one, when there are multiple sets of parentheses, start on the inside. So, what is the sine of 5 pi over 6? Okay, so first of all, sine of 5 pi over 6. 5 pi over 6, if you notice, is going to have a reference angle of pi over 6, correct? It is only pi over 6 away from pi, has a reference angle of pi over 6. What is the sine of pi over 6? Sine of pi over 6 is 1/2. Right? This is all based on a chart. What do we know about sine in quadrant 2? All students. So quadrant 2 is positive, right? So, sine of 5 pi over 6 is 1/2. Now, did some of you catch that's also the 1/2 that's in the ordered pair there? Okay. You can, you just won't always have all these details. That's the key. You have to be able to find that reference angle. Okay, so now if I put that 1/2 on the inside, what is the sine inverse of 1/2? Pi over 6? Why not 5 pi over 6? Okay, so this is the one where this is kind of the opposite of last time. You have to be careful here. Yes, that sine inverse and sine are going to undo each other, but you can't tell me a sine inverse answer is 5 pi over 6, because 5 pi over 6 is over here in quadrant 2. Where do all my sine inverse answers have to be? Quadrant 1 and 4. I can't give an answer over here. So, that's why you have to think about where does sine equal 1/2. And sine equals 1/2, still at pi over 6. You guys understand why I did that? And again, it comes back to flip over to the back side where my answers can only be from negative pi over 2 to positive pi over 2. I can't have an inverse answer on the left. Okay, F. Sine inverse of negative 1. Okay, so what do we know, guys? Where does sine equal negative 1? At what angle does sine equal negative 1?
3 pi over 2.
Okay, so remember an ordered pair is cosine sine, and so the negative 1 down here at 3 pi over 2. Now, I know this was not given as an answer. I heard people already get it right, but I'm going to write this down temporarily. Can I leave that as my final answer, though? No, why not? Okay. 3 pi over 2 is not in my range. So, what is 3 pi over 2 equivalent to that is in my range? Negative pi over 2. In other words, even though we call it 3 pi over 2, if we're going positively, what is that angle if we're going negatively? Okay, got the idea of how those work? Okay, you will see multiples in homework that will say, give me an exact answer. That's what I'm looking for, guys. I'm looking for you to use your brain, the unit circular chart, think it through. Real quick, the next section says use a calculator in what? Radian mode to evaluate these inverse sine functions. All this is a quick little practice with your calculator. Okay, guys, sine inverse. Can you use your regular sign and raise it to a power number negative 1? No. You have to use your second sine function. Type it in. Make sure you're getting the same answer as me. I don't think you need much more direction than that for me. Let me know if you don't get the same answer. Go to your mode button, which is up next to your second button. Okay? Yeah, mode. You go to your mode button, which is next to your second button. There's a free gradient option there. If you haven't changed it for a while, I've already forgotten.
Why does yours not have like a negative 0 point?
Because I didn't bother typing the 0 because it's unnecessary.
Oh yeah, that makes sense.
Oh, because it didn't come up with the answer? Well, let's see.
Oh yeah, I was talking about the answer.
I wasn't talking about the answer. I don't know. Does yours have a 0?
Yes. I've noticed that before, but like it's kind of
I don't like it. It's probably somewhere.
it is kind of annoying. 'Cause, like,
There's probably a setting somewhere, but I have no idea. I've never, okay, so I have never purposely set that setting. Everyone's questioning why mine doesn't say 0.944. I have no clue. It's not a setting I've ever set on purposely, but there's probably a setting that it will change it. Do you guys have float on yours?
Yeah.
Normal float, auto, real, radian, MP? Okay, I don't know. I'm going to give 3 decimal places. Negative 0.944. Okay, can you do B then? Type it in. Notice it's sine inverse, then regular sine of 3.49 pi. Make sure your answer matches my answer. Did we get it?
Yes.
If I need to help you with calculator issues, let me know, please. This is the best time for me to figure out calculator issues, as opposed to you getting home and trying to do homework tonight and struggling alone. So. Yeah.
We do the next one.
We might be doing 3, so never mind.
Okay. Pi is your second function on the arrow button, on your exponent button, if that's what you're asking.
I got it there. What was it? I don't think I did it right.
If you get an error message, I agree. You didn't do it right. I don't know what you didn't do right, but you did do it right.
You don't understand. Oh, I thought you would have. Yeah, it doesn't have that. No, I hit program.
Okay. Calculator's cooperating with you? Okay. Now, we need to talk about inverse, cosine, and tangent. Needless to say, these pieces are going to work very similar to what we just experienced with sine inverse. Couple slight differences, though. Okay? Which, by the way, for those of you that weren't here on Friday or have just honestly since forgotten, I mentioned on Friday, and I have it written here if anyone saw it, sine inverse x. An equivalent way of saying sine inverse x is to say arc sine x. You will see that in homework some. So, just kind of an FYI there, you will see arc sine x. It's asking the same question as sine inverse x. Okay, now, I mentioned that because cosine and tangent are going to have the same issues, in that they will have the arc cosine x or tangent or arc tangent x. Now, a couple of things. If you noticed on the back side, one of the half circles is different there. So the inverse cosine function, it still has the same domain of -1 and 1, just like sine. However, this is important. What do you notice about the range? 0 to pi. Okay, 0 to pi. If you're looking at your half circle, what do you notice about the cosine range? Instead of being the right side of the circle, it is the top side of the circle. Okay? Inverse tangent. Inverse tangent is also a little different. It has a domain of negative infinity to positive infinity. That means we can put anything we want into inverse tangent. Its range is similar to that of sine. Negative pi over 2 to positive pi over 2, except it's parentheses instead of brackets, which means it cannot include negative pi over 2 and positive pi over 2, but it can include everything up to those points. If you flip to your backside real quick. Okay. We already talked about sine inverse, right? So now we have cosine inverse. These are your range values. We also have tangent inverse. These are your range values. Again, if you can just kind of memorize these triangles, half circles, that would be good. Okay, so with cosine inverse, you're going from 0 to pi, which means you're going from 0 to 180. Now, tangent inverse, notice, what is there where negative pi over 2 and positive pi over 2 are supposed to be? X, indicating you can go all the way up to that, except you can't use that. Okay, so just kind of an FYI there. Work on knowing those circles, or those half circles. As we work towards preparing for a test next week, and we work towards, you guys have the unit circle that you're allowed to use on the test, and you're allowed to have some notes on. These half circles would be something good to put on your notes page. Okay, I'm not saying you need to do it right now, but, you know, it's something that we'll talk about later. Yes, Holden?
What day are we thinking test is going to be?
I really can't answer that question until I see how the weather pans out this week. It could be as early as Tuesday next week.
So we're thinking trash football Monday. Yeah.
Hadn't played. Oh, crud.
Oh, man.
Yeah, we could play trash ball Monday.
We don't have school.
Monday's President's Day, so as of right now, we don't have school.
Oh.
We have e-learning.
No, we don't even have e-learning as of right now. Yeah. Okay, so, anyways, yeah. The earliest the test would be Tuesday, but when I said that, I was thinking we had school Monday. I don't know when the test will be. That is still the earliest it would be. Okay, guys. I want to try and get as many of these done as we can. If we don't finish them, we don't finish them, but, okay, focus. Cosine inverse of negative square root of 2 over 2. First of all, is that an appropriate domain entry? Because the domain of cosine is negative 1 to 1. Square root of 2 divided by 2. It'd be like 1.4 divided by 2. So that's like 0.7 or something. So that is an appropriate domain, which I always want to check. Now, forget the negative for a moment. Where do you know cosine equals square root of 2 over 2, according to your chart? Pi over 4, yes? So if we were just asked, what is the cosine inverse of square root of 2 over 2, you're going to say pi over 4. Now, it says negative square root of 2 over 2. Think carefully about what quadrants you're allowed to answer this in. Cosine is a 0 to pi option, right? So can I just say that, well, since it was pi over 4, now it's negative pi over 4? No, because negative pi over 4 would be down here in quadrant 4. What is equivalent to pi over 4 in quadrant 2? 3 pi over 4. Yes? So this is 3 pi over 4. And again, that is an appropriate range value. And notice along the way, I had to think pi over 4 to get there. But then we had to go for quadrant 2. Okay. Tangent inverse of square root of 3. First of all, I guess I should ask, is square root of 3 a good domain input value? Yes, because for tangent inverse, I'm allowed any kind of domain I want. Okay, so Where does tangent equal square root of 3?
Pi over 3. Oh my gosh, you're right. You're right.
Yes, you're right.
Here?
I'm trying to figure out why everyone's so confused. Are you guys looking at your chart?
I was using the circle, that's why I was.
Okay. So, easiest thing to do in this case would be use your little trig reference chart we quizzed over last week, because that has tangent on there real easy, right? Tangent of pi over 3 is square root of 3. So tangent inverse of square root of 3 is pi over 3. That's a positive. We're in quadrant 1. Piece of cake. Now, if you're trying to look at the reference circle, remember tangent is y divided by x. And so if you look at y divided by x here at pi over 3, it'd be square root of 3 over 2 divided by 1 over 2. The 2's cancel, and so it's square root of 3 over 1. So you can use the unit circle. It just you have to think a little harder about it. Now, because I'm running out of time, I'm going to skip C for a moment, because C is a little bit of a challenge. I want to get some basics with D and E out of the way. And if we have time, we'll come back to C. Okay? Let's talk D. Tangent inverse of 0. Chart was all nicely helping us, wasn't it? Okay. What do you know about tangent? I just said tangent is what is a fraction? Y divided by x, yes? And right here, 0. So what's that mean? Y is 0. So where on your unit circle is y 0? Okay. So here on my unit circle, y is 0 at, I'm going to say 0 and at pi. Okay. Now, 0 or pi? Which answer do I need to give since this is tangent inverse? 0. Because where am I only allowed to give tangent inverse answers? The right half of the circle. Just like sine inverse, you're only allowed to give answers on the right half of the circle. So you can only look over here. Well, my options are here at 0 or here at pi. So 0 is the one that has to work. So what is tangent inverse of 0? 0. You just have to find the right way to think about it. Okay. Cosine inverse of -1. Where does cosine equal -1?
Or 0.
For -1? The only place cosine ever equals -1 is at the ordered pair, -1, 0. Because remember, it's cosine, sine. And that happens at -1. And so that angle is pi. Can I give pi as an answer? We couldn't give pi back here on tangent inverse. Can I give pi on cosine inverse? Yes, because cosine is the top half of your circle. Look back to those half circles on the back of the page. Cosine is the top half, so you can give anything 0 to pi. And so this is pi. Okay?
We'll have this handy dandy circle on our test.
Yes. And I've been telling you guys that all along.
I've been writing stuff on it, but I just thought I had been writing it and then
I mean, okay, so here's what it will be, guys. Listen, test time, you get to use your unit circle. I have told you up front, you can put your chart on it. The trig reference chart to be quizzed over. Because here's my deal, guys. Yes, I want you to have it memorized. However, if you lock up or space or something on the test, and you don't remember your chart, I've just set you up for failure. Okay? And I'm more about, for this test, do you know the idea of how everything works within trig? Okay? Yes. That is what I mentioned a couple minutes ago. That I think holds thinking about, yeah. So yes, you can draw your half circles on the back. Okay, where am I at on time? Oh, I lost my screen.
Last one.
Okay, guys.
I'm guessing it does not exist.
It's fake.
Not real.
Okay, guys, here's what you have to think. I'll try and talk as much of this one as I can. I'm going to kind of shortcut it, to be honest. Generally speaking, cosine inverse and cosine are going to do what to each other? They're going to cancel each other out. As long as we're in the right quadrants. As long as we don't switch quadrants. And that's the catch you have to watch out for. Okay, so first of all, cosine of negative 1.1. If you do you have to figure out where that is. Because negative 1.1 is an angle. And negative 1.1 as an angle is obviously less than 0. But if we think about, like, this is 0 and this is negative pi divided by 2, well, this is then negative 1.57. So the idea is that negative 1.1 is down there. Now, we then are being asked about cosine inverse of that angle. Where's my cosine inverse have to happen? Up here. So, the idea is that cosine inverse of negative 1.1, cosine of negative 1.1 would give me some answer here. I don't know what the exact answer is because it's not one that's on my chart. But what do we know about cosine in this quadrant? All students take calculus. Cosine is positive. Where is cosine inverse positive? Up here in quadrant 1. Because it's positive here and negative here. And the equivalence of a negative 1.1 down here is equivalent to a positive 1.1 up here. And so your answer is positive 1.1. Whoops, and Now, I know that's quick to explain, but I also know the bell's about ready to ring on. Okay? Your homework, 1 through 20, 23 to 32, on page 385. Have it ready to go for tomorrow.
Yes.